Sounds Maths channel. I'm now answering question number 6 from the May-June 2024 paper 2, variant 2 of Mechanics M1 from the 9709 Cambridge exams. This question is about 3 particles A, B, and C, which have masses 5, 1, and 2 kilograms respectively. They lie at rest in that order on a straight, smooth horizontal track X, Y, Z. Initially, A is at X, B is at Y, C is at Z. So let me just make a diagram. With these kind of questions, it's always best to make a clear diagram to show what's happening. So we have these 3 particles, A, B, and C, in that order. A, you got B, and you got C. Okay, they're at the points X, Y, and Z on this horizontal, smooth horizontal track. There's no friction involved. So this is X, this is Y, and this is Z. This is the particle A, particle B, particle C. A has a mass of 5 kilograms. B has a mass of 1 kilogram. And C has a mass of 2 kilograms. Okay, so that's up to this point here. So we know that the track is smooth, and it's also horizontal. So it's smooth. There's no friction. Horizontal, we don't have to worry about the components of their weights, affecting their motion. So initially, particle A is projected towards B with a speed of 6 meters per second. So particle A is projected towards B with a speed of 6 meters per second. And at the same instant, C is projected towards B with a speed of V meters per second. This direction with a speed of V. Okay. In the subsequent motion, A collides and coalesces with B. A collides and coalesces with B. Now the word coalesce in this type of question means that A and B basically join together and start moving as one particle. Okay. So what's happening is A is going to move. It's going to hit B. They're going to join together. So when it hits B, they're going to be at that position here. Okay, so what's going to happen is these two are going to collide over here. So this is after the collision, and together, let's just draw them as one big particle. It's like they become one particle. Right, so this is 6 kilograms now. And at the same instant, C is projected towards B with a speed of V meters per second. In the subsequent motion, A collides and coalesces with B to form particle D. So this is now particle D. D is like A and B joined together. Okay, and particle D then collides and coalesces with C to form particle E. Okay, so then C is moving towards D, D is moving towards C. When they collide, then the particle E is formed. It says here, show that particle D then collides with C to form particle E, and E moves towards Z. So then once C and D both collide, they both move towards the side Z or Z. So now, show that after the second collision, the speed of E is 15 minus V over 4 meters per second. All right, so the second collision is when D and C collide. D is going to be moving this way, C is going to be moving that way. They're going to collide somewhere, and they will form E, and then the speed of E after that collision is going to be what we're looking for here. So first, I think we need to find what is going to be the speed of this coalesced particle after the collision of A and B. Now, so let's look at first before the collision of A and B. Before the collision of A and B, B is going at 0 meters per second because it's at rest. And before the collision, A is going at 6 meters per second towards B. It will hit B over here. And after the collision, they'll both be going together at the same speed, which we'll just call the velocity of D. Okay. So now, how do we find that? We can use the conservation of linear momentum. We know that the total momentum before the collision is going to be given by this information up here. So the momentum is the mass times the velocity. So in this case, it's going to be 5 times 6 plus, and here you're going to have 1 times 0 is equal to the total momentum after the collision, which is given by what's down here, which is basically 6 times VD. So you end up with 6 times 5, which is 30, divided by 6, which is 5. So VD is equal to 5 meters per second. The velocity of D is 5 meters per second. That's how D moves after the collision, 5 meters per second. And then C is going to collide with D. Okay, C is going to collide with D. It has a mass of 2 kilograms. And C is moving in this direction with a speed of V. Okay, before the collision and after the collision, they're going to form. Let me just, okay. So this is going to be now before the collision, this new collision. Okay, it's going to be before the new collision. After the new collision, they're both going to form one big particle, E, which is 8 kg, and we want to find what the velocity of E is. That will be our answer. So we're going to look at, this is the conservation of linear momentum when A collides with B. A with B to form, that forms the particle D. A with B to form D. And now we're going to see the conservation of linear momentum, okay, of the D with C. D with C. Okay, that's going to be this one here when these two collide. So we see before, you're going to have the situation where you know this is now 5. So it's going to be the mass, which is 6 times 5, plus the mass of C, which is 2 times. Now we are taking, obviously, this side as positive so far. So we know C is moving in this direction, so it's going to be minus V. Whatever speed that is, it's going to be negative. So we put minus V. Okay, V stands for speed, so we put minus V so that we understand that it's going to be in this direction. Okay, that's the momentum before, and after the momentum is 8 times VE. 8 times VE. And we have to find what VE is. Okay, so if we take this, we have 30 minus 2 V equals 8 VE. And then we can basically divide both sides by 8. So VE equals, before I divide it by 8, I'll take 2 out as common. So that's 15 minus V over 8. 2 and 8 cancel to give you 4. So the velocity of E is going to be 15 minus V over 4, which I think is that's what we had to show. 15 minus V over 4 meters per second. So there is the answer to part A of this question. Okay, now for part B, it says the total loss of kinetic energy of the system due to the 2 collisions is 63 joules. Use the result from part A to show that V equals 3. So the loss of kinetic energy means the kinetic energy before minus the kinetic energy after the both collisions is going to be equal to 63 joules. Okay, so what is the kinetic energy before the collision? Well, it is the total kinetic energy before any of the collisions occurred. So it was A was moving at 6 meters per second and C was moving at V meters per second. Okay, A has a mass of 5 kilograms and C has a mass of 2 kilograms. So we know that kinetic energy is given by the formula 1/2 times the mass times the square of the velocity. So for before the collision, you have the kinetic energy of A, which is 1/2 times 5 times 6 squared, plus the kinetic energy of C, which is 1/2 times, is it 2 times V squared. Okay, it's going to be squared, so you don't have to worry about the sign. So 1/2 times 2 times V squared. Okay, minus the kinetic energy after. So at the end of all the collisions, what's happening is you have just E moving, okay, with a velocity of 15 minus V over 4 meters per second. So the mass is 8. It's the combined mass of all of them. So minus a half times 8 times the velocity, which is 15 minus v over 4 all squared. And that has to equal 63 joules. So we can use this now to try to find the value of v. So we're going to have a half times 5 times 36. That's going to be 90, because half of 36 is 8 times 18, times 5 is 90. So you have 90 here. And then you have a half times 2, which is 1 times v squared. And then we got a half times 8, which is 4. Okay, now you're going to have this 4 all squared, which is 16, so it'll be 4 over 16. And then you're going to have 15 minus v squared. I'll just leave it like this for now so we don't get confused. 15 minus v all squared equals 63. Now this 4 and this 16 cancel to give you 1 over 4. Right? I think I'm going to make life easier to get rid of the fraction. I'll multiply. Don't forget to multiply everything by 4. Okay, both sides by 4 and all the terms by 4. Okay, so this is going to be 4 times 90, which is 360. 4 times v squared, which is 4v squared. 4 times 1/4, which is 1. So you're going to end up with minus. This is 15 minus v squared. And equals 63 times 4, that's 240 plus 12, that's 252. Okay, so now we have 360. So we're going to have, I'll just do 4v squared minus, this is going to be 15 squared, which is 225. And when you expand this, you have 2 times 15 times minus v, which is minus 30v, and plus v squared. Okay, and minus 252 equals 0, because I can see we're going to have a quadratic here. Okay, so that's the 360 plus, sorry, I forgot the 360. Okay, so now we're going to have 4v squared. I'll do this in one go. So you got 4v squared minus v squared, which is 3v squared. You're going to have minus 30v, which is plus 30v. Okay, and then you're going to have 360 minus 225 minus 252. So you got 360. You have 360 minus 225 and minus 252. That gives you minus 117 equals 0. Now, can we solve this? Can we make it easier? They're all divisible by 3 because these add up to 9. So 3, okay, so 3 goes into all of them. So that's v squared plus 10v minus 3 goes into 11. 3 times remainder 2, 39 equals 0. And it says show that v equals 3. So that means v minus 3 must be one factor. Okay, and the other factor is going to be v plus 13, because they have to add up to give you 10 and multiply to give you negative 13. So therefore v is equal to 3 and v equals negative 13. You can't have v equals negative 13. So therefore, well, they told us to show that v equals 3. So v is equal to 3. All right, and there's the answer. Okay, we know that C is moving towards Z. E is moving towards Z anyway. They told us E moves towards Z, so we've taken that as positive. So it must be in that direction. So V is 3. Okay, so we can say the velocity of E is 15 minus 3 over 4, which will be 12. So we can work out now the velocities of these in the situations if we need to, probably in the next part of the question. So there's the answer to part B. Now, part C, it says, is given that the distance xy is 36, the distance yz is 98, find the time between the two collisions. Okay, so I'm going to make a new diagram so that we don't have all that unnecessary stuff there. So we have x, that's where it started A. That's A, 5 kilograms. Then we have y, That's B. Then we have Z. That's C. That's 5. That's 1. And that's 2 kilograms. 8 kilograms altogether. So it says the distance between X and Y is 36 meters. So this distance here is 36 meters. I'll just do it this way. Okay, so this distance here is 36 meters. And this distance here is YZ is 98 meters. So here we have 36 meters and here we have 98 meters. So we're going to find the time between the two collisions. So the first collision took place when A hit B. Okay, when A hit B. Okay, let me draw A separately. Okay, so the first collision took place when A hit B. Okay, so the time between the two collisions. So A hits B first at Y. Okay, so A hits B at Y first. Okay, and then what happens is this continues on and C's starting off. So basically what happens after A hits B, okay, after A hits B, this is moving at a speed of 5 meters per second. Okay, and how many seconds did it take for A to hit B? We've got to work that out. Okay, now A hits B, A travels 36 meters. Okay, and so when A hits B, okay, it travels 36 meters, okay, at 6 meters per second. Okay, so therefore it takes it 6 seconds. Okay, so 6 seconds, right? At a constant speed of 6 meters per second. So it's taken 6 seconds for A to hit B. Why is that important? Because that same 6 seconds, C is moving in this direction at a speed of 3 meters per second. Okay, so C has moved how long? C has moved for 3 seconds in this direction. C has moved 3 meters per second in this direction for 6 seconds. Okay, by the time A hits B, C has been moving for 6 seconds. So C, okay, has moved in 6 seconds at 3 meters per second. How far? All right, so we can use its constant speed here, constant acceleration. We know the speed equals distance over time. Why? Because it's constant speed. So he's going, his 3 is equal to the distance he's traveled over the time, which is 6. So the distance he's traveled is 18, okay, meters. So C has moved 18 meters in this direction at the point when A hits B. Okay, so it's traveled 18 meters, C, when A hits B. Okay, so how much distance is left between them? 98 minus 18, which is 80 meters. Okay, so now at the point when B starts, D is moving towards C. Now D is moving at 5 meters per second. Okay, and C is moving at 3 meters per second. And the distance between them is how much? The distance between them is 80 meters now. Because by the time A hits B, 6 seconds has passed. Okay? Because we know that speed equals distance over time. So we know that time equals distance over speed. So the distance is 36 over 6, which is 6. Right? It's going at constant speed. We can use this formula for constant speed. All right, so now this is moving 5 meters per second, and this is moving at 3 meters per second. Okay, and the distance between them now is 80 meters, and we want to know what time that they're going to collide in. Okay, the time that they're going to collide. All right, So that's what we have to work out here. Okay, so basically, this is going to travel further than this. There's going to be proportion between them. So basically, the total distance they're going to travel is going to be 80 meters. So if you split 80 in the ratio of 5 to 3, we split 80 in the ratio of 5 to 3, because they're proportional, okay, then this will be 5 over 8 times 80, okay, 5 over 8 times 80. So no, it's going to be inversely proportional. Why? Because the one traveling faster, okay, will take less time. Okay, yeah. So basically, this is going to travel 50 meters. This is going to travel further. So he's going to travel 50 meters. Okay, and he's going to travel 30 meters when they collide, basically, right? So there's 80 meters to cover altogether. He's going 5 meters per second this way. He's going 3 meters per second that way. So basically, they're going to collide when this has traveled 50 meters and this has traveled 30 meters. That way, it's a total of 80 meters. So how long does it take for that to happen? It's the same time. It's going to be speed equals distance over time. So time equals distance over speed. So whichever one you use, you're going to end up with 10. That's 10 seconds. Okay, so from the time it takes from the first collision to the second collision is going to be 10 seconds. Because when A hits B, that's the first collision, that's when D is formed. There's 80 meters left between them at that time. And then the time between that and the first collision is going to be 10 seconds. So it's 10 seconds between the two collisions, the first and the second. The answer is 10 seconds. All right. So basically, it's a bit of a complicated one. First, A hits B. It takes 6 seconds for A to hit B because it's traveling at 6 meters per second. Okay. For 36 meters, that's 6 seconds. In that same 6 seconds, C has been moving towards B. It's been moving towards this point Y. All right. So in 6 seconds, it moves 18 meters. All right. So there's 98 meters between them. These two, okay, and in that 6 seconds, this is going to start now moving this way, okay, as a combined particle with A, at 5 meters per second, and this is now moving at 3 meters per second. They have 80 meters to cover, so this is going to travel 50 meters, this is going to travel 30 meters when they collide. That's the second collision. That's going to take 10 seconds. So from the time of the first collision to the second collision is 10 seconds. And now for part 2, it says find the time between the instant that A is projected from X and the instant that E reaches Z. Okay, so now we've determined it took 6 seconds. So for A to get to the point Y, okay, that took 6 seconds. And for the combined particle C to get to the point, or to collide with is it C? Sorry, D. For D, the combined particle D to collide with C, that took 10 seconds. And then for E to get to X, we've got to work that out. All right. So now E is moving at a speed of, what was the speed it was moving? We got that in the last page. It was 15 minus V over 4. So E is moving at a speed of 15. So the velocity of V is 15 minus V over 4. So that's 15 minus 3 over 4. That's going to be 12 over 4. That's 12 over 4. Is that right? 15 minus 3 is 12 over 4. So it's moving at 3 meters per second. Okay. In this direction. Okay, so that's the velocity of E. Okay, that's right. So it's moving 3 meters per second, and it's moving a distance. Okay, so this was 30 meters. This has moved 30 plus 18 meters. So it's moved. It has to move because at the point where they collide is 30 meters away from here. That's 30 meters from. Is it 30 meters from where? Yeah, 30 meters from where C was at that point. So it's 30 plus 18, that's 48 meters. So basically, it's moving 3 meters per second for 48 meters. So the time is equal to the speed equals distance over time. So time is distance over speed. So it's 48 over 3, which is that's 16 seconds. So that's going to be plus 16 seconds. So you have 10 plus 6, which is 16, plus 6, which is 32 seconds. It's going to take 32 seconds for it. Altogether, the time between A was projected from X and E goes back to Z. Okay, so that's the answer to part, C, part 2. Okay, so a little bit tricky at the end. Okay, sorry about my bad handwriting, but we got there in the end. Okay, so there's the answer to this question. Other questions from this particular paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from this topic of momentum, I guess it's all about momentum, in this playlist over here. You can subscribe to my channel by clicking on this link, and the link up here will take you to a video which shows you how to use my channel in an efficient manner. Thank you for watching and see you soon.